Halo, Assalamualaikum warahmatullahi wabarakatuh. My name is Zalfa Nurul Aini. My friend usually call me Zalfa, and I'm from the Department of Chemistry, Chemistry A, Faculty of Science and Technology. And I will explain about aeration, review wastewater treatment, drinking water treatment, and coagulation and flocculation. Okay, let's go. The first, aeration. Aeration is the process of contacting or touching water and oxygen with holes for oxygen to enter. Oxygen is very reactive because it enters periodic group 6 when it bonds with two free electrons. Aeration serves to increase dissolved oxygen so that the ions are good in the water and can be drunk. Aeration is divided into two, namely natural aeration and artificial aeration. Natural aeration is when the water is placed in the river, which is a sign that there are a lot of fish and the dissolved oxygen is very large. Therefore, it is favored by many biota. Then, artificial aeration, namely in the aquarium, there is an aerator that pumps air into the aquarium. If the aerator is turned off for a day, the water will be cloudy and the fish will die. This is because the oxygen in the aquarium is reduced because there is no air entering. Aeration of great benefit is the beach waves. On the beach, the sand is in the form of fine grains derived from sea water which has a lot of ions. When it encounters dissolved oxygen from the aeration process in the waves, the next process is minerals in seawater to form their oxides. That's what gives rise to sand. In waste treatment, if there is nothing else to filter, the microbes will decompose organic compounds by contacting oxygen and they will settle. Membrane diffuser for pumping air. Surface to help water circulation. Aerotube diffuser to provide high oxygen transfer rates and a more efficient system. The second is review wastewater treatment. Alum. Alum with the chemical formula Al2SO3 is used to treat dirty water to become clear. Samples of dirty water are taken from urban areas, then processed. Divide the water sample into containers, and then one of the containers is given alum and stirred. Stirring here serves to make it settle faster. It can be seen that the comparison of the two containers, the container that was given alum was clearer than the container that was not given alum. After filtering the container with alum, it can be seen more clearly like clean water. Alum work can be able to agglomerate dirt. Previously, the colloid system always repel because the charge is the same, so it was still cloudy. Then, when given a coagulant will settle, the coagulant is able to change from a state of repulsion to attraction. Now, this can be done in layers, namely layer 1 is attracted, then layer 2 is attracted, and so on until it settles. The third is drinking water treatment. There are various kinds of water treatment. Some are to be discharged into the environment and some are for drinking water. Be more careful in processing it. Fishery water, industrial water, etc. Water treatment stage 1. Screening. Water enters the container for filtration. 2. Coagulation. or coagulation/flocculation, after being given alum or coagulant with the help of stirring, the interaction will settle more easily. 3. Clarification or sedimentation. Then it enters the sedimentation basin and moves very slowly so that it can be deposited. 4. Filtering. Usually there is also called a slow sand filter. Sand in paste, then the water is made very slow. The function of the sand is to bind with absorption events. And the fourth, coagulation and flocculation. Coagulation is the addition of chemicals to destabilize the electrostatic forces of non-stable solids. Coagulant chemicals typically have a positive charge, which binds to the negatively charged particles in water, neutralizing them and allowing them to come together to form small clumps of particles called microfloc. In most cases, the chemical reaction occurs in a fraction of a second. So, it's important the coagulant is dispersed quickly and evenly to encourage as many particle collisions as possible. Because this process relies on chemical reactions, several considerations must be made. Water temperature, for example, colder water usually slows coagulation and flocculation reactions, which may require more time to achieve optimal floc formation. Extreme values of pH high or low will also interfere with the process. Coagulant effectiveness is highly dependent on pH. For some coagulants, alkalinity is a factor. Operators may need to raise out validity for coagulation to be effective when using iron or aluminum coagulants that can consume alkalinity and depress pH when they are added to low alkalinity waters. Turbidity is also important. The lower the turbidity, the more difficult it is to form proper floc. The most common coagulant chemical used is aluminum sulfate, commonly called alum. When added to water, alum forms jelly-like particles of aluminum hydroxide. The traveling aluminum ions neutralize and attach to negatively charged particles in water, forming microfloc. Alum works best in a pH range of 5.5 to 7.5. Polyaluminum chloride and iron salts such as ferric chloride and ferric sulfate are also used. They operate over a wider pH range. Coagulant and flocculate aids are added to improve binding, build stronger, more soluble floc, and effect flocculation by increasing floc ice strength and or floc density. In addition, they help overcome the effect of low temperatures, reduce the coagulant needed, and reduce the amount of sludge produced. Commonly used coagulant aids include cationic polymers. Polymers are defined as a synthetic compound with high molecular weight and composed of repeating chemical units or monomers. Polymers may be polyelectrolytes such as the water-soluble flocculations, water-insoluble ion exchange resins, or insoluble uncharged materials. Polymers are long chains of molecules that produce highly charged ions and help bind microfloc together into larger floc particles. They are very popular with operators because they are very effective and can be positive, negative, or neutral ion charger, providing a great deal of flexibility in different circumstances. Maybe that's enough for me. Thank you for your attention. I'm sorry if there was mispronunciation from me. Wassalamualaikum warahmatullahi wabarakatuh. Bye bye.